So, by the way, this is a continuation from last week's discussion on the AVR, the Atmega Atmel processor. So we're talking about the AVR, the I/O, GPIO, how do we control the registers to set the direction of the GPIO pins, etc. So this is a continuation from that part. So the next 6 slides, I will talk about the timer and the counter in these processors. You will find timer and counters in almost all the microcontrollers that you will use, and they are useful, of course, for time-related functions, for counters, and in some cases for generating timer interrupts or PWM waveforms. And in this case, this Atmega 328P has 3 timer and counter modules, T0, T1, T2, or TC0, TC1, TC2. Those are hardware counter modules, and they have slightly different function, as you can see here. You can use them in different ways. For example, difference between TC0 and TC1 is the number of bits. So the granularity will be different. The scale will be different. And also you can choose different inputs for TC2. We typically use counters and timers for counting clock cycles. If you want to generate time, or measure time, that's definitely you have to use timer registers, counter registers. You can count external events using rising or falling edges, and you can generate time delay. You can generate pulses and PWM waveforms, and you can also trigger interrupts. This is the internal diagram for this timer counter module. You see a few names that you will find out later, the TCNT and OCRN and OCA, OC and B. So these two are the outputs that will generate when you use PWM. When you generate PWM waveforms, this is where the outputs will be. And TCN, T counter, and OCR, these are, and also TCR, A and B. So those are the registers related to this counter module. Again, when you deal with these microcontrollers, you're essentially programming these registers. So if there's one thing you should learn from this class is that if you program these microcontrollers, underneath, you're really operating or programming their registers, especially these special function registers. TC0 is the configurable timer and cycle counter with the PWM generator. So there are 3 registers related to this function: TCNT0, TCR0A, TCR0B. So if you want to operate TC1, so you can expect this number here will be a 1. And these are the IO address and load store address. Depends on what kind of instruction you want to use to access them. You will use different addresses. This TCNT0 stores the clock cycle count. So because it's 8-bit, so we're already talking about 256 values. It's a modulo 256 counter. And TCR and TCCR 0A and 0B, these are special, these are configuration registers to control the timer operation. For example, if you want to use the timer module, use it as an incrementing counter, you can set these bits to be 0, these bits to be 0, and these bits to be 0, and these bits to be 001. And then write initial value to this T0 and T0. Now, how do we know these bits? And you need to go into the data sheet to find the configuration information, to read the description of these registers, and set the values properly. That's where you need to pay attention when you program this chip or a different chip. You have to refer to the data sheet a lot to understand how to set these configuration bits. You may wonder, oh, we didn't have to do that using Arduino. You're right, because you use a lot of libraries. And those libraries, underneath, they did the hard work by setting up these individual bits in the configuration registers, control registers. And we're gonna talk more about that in the next few classes. Next thing is the clock select. For this particular chip, you can use these 3 bits to select the clock input, to use no input or do some kind of a scaling. This is called pre-scaling. Pre-scaling is where we can scale down the clock. By scaling down, we mean we divide the frequency by a number, by 8, by 64, by 256, by 124. If we do that, we essentially can count for a longer duration. So I'll give an example here. Arduino Uno, its clock is 16 megahertz. So the duration of the clock period is 62.5 nanosecond. If we don't do any pre-scaling, the T1 counter will give you this. You will use this as the clock duration, and that will give you 256, because your counter can count up to 256 times. So this will be the clock duration times 256. That will give you 16 microsecond. Now, if you do pre-scaling, so you can divide the frequency by 1,000, and that means you will increase the clock time by 1,000, but your clock period by 1,000, 24 times. So you essentially will be 1,024 times of this 16 microsecond. So that will give you about 16.384 millisecond. Okay, the next thing we can do with this timer is to generate PWM waveforms. And for this particular timer 0, we use OC0A and OC0B, those 2 outputs, and that's connected to pin 6 and pin 5 of the chip. And then this is how you actually access these registers at different addresses internally if you want to do that. Let's see. For waveform generation module, if you want to generate PWM, you can use these several bits, which are, let me go back here, actually here. So we can use these 3 bits, these 2 here and this one here, to basically select how we want to generate a waveform. You can, this module, these modes permit fine-tuning with the PWM. You can use these 2 registers to control the duty cycle, which is often the time we do that. When you do the DC motor control for the 3rd lab, you actually have to change the PWM, the duty cycle, to change the speed of the rotation. You can do a few other things. Okay, so that was the a very quick introduction about the timer and counter module in this AVR processor. With that, I will end